Okay, so today we're looking at section 4.4, properties of logarithms. We have two in general. We have the product property of logarithms. If you let b, x, and y be real numbers, where b is not 1, then the log base b of xy is the log base b of x plus the log base b of y. In other words, the logarithm of a product equals the sum of the logarithm of the factors. We have a quotient property here. Again, letting b, x, and y be real numbers, b not equal to 0. The log base b of x divided by y is the log base b of x minus the log base b of y. In other words, the logarithm of the quotient equals the difference of the logarithm of the numerator and the logarithm of the denominator. Lastly, we have the power property of logarithms. It says let b, x, and y be real numbers again, where b does not equal 1. Then let p be a real number. Then the log base b of x to the p is equal to p times the log base b of x. So let's look at some examples of this real quick. All right, so let's start off simple. And we'll start off with the log base 4 of 16 times a. Well, this is the log base 4 of 16 plus the log base 4 of a. We can go a little further. This is 4 to the second, so this is 2 plus the log base 4 of a. Not necessary, really. This would be sufficient for now. Simple addition, product rule implications. Again, what if we have the log base 6 of 8 over t? Well, this is simply the log base 6 of 8 minus the log base 6 of t. Okay, what if I have this? The natural log of x to the 4th. Well, this is simply 4 times the natural log of x. So that's our three properties. So now let's look at something a little more complex. How about the natural log of a to the 4th b over c to the 9th? So I'm looking at the natural log of a to the 4th times b minus the natural log of c to the 9th. Okay, so let's break this down some more. This is the natural log of a to the 4th plus the natural log of b minus 9 times the natural log of c, right? Exponent of 9. Now we can get rid of this exponent here. 4 times the natural log of a plus the natural log of b minus 9 times the natural log of c. Okay, so what about going the other direction? What if I have the log base 3 of 54 plus the log base 3 of 10 minus the log base 3 of 20? So what is this? Well, the addition implies multiplication. Log base 3 of 54 times 10 divided by 20. So that's the log base 3 of 540 divided by 20. Log base 3 of what, 27? Which we can figure out is 3. we can look at this further. Say I given the log base b of 2 is approximately 0.356, and the log base b of 3 is approximately 0.565. Can we guesstimate the log base b of 24? Well, what is 24? This is a log base b of 2 times 2 times 2 times 3, right? That's 24. 2, 4, 8, 24. So this is the log base b of 2 to the third plus the log base b of 3, which would be 3 times the log base b of 2 plus the log base b of 3. I'd have 3 times 0.356 plus 0.565. Do some calculating. 3 times 0.356 plus 0.565, and I get approximately 1.633. Okay. Now, as we pointed out, we can find the common logarithm and the natural logarithm because our calculator has those on them. However, if we have something else, we can still find it. So if we let a and b be positive real numbers such that a doesn't equal 1 and b does not equal 1, then for any real positive numbers, x, the log base b of x is equal to the log base a of x divided by the log base a of b. Note, the change of base formula converts a logarithm of one base to a ratios of logarithms of a different base. For the purpose of using a calculator, we'll often change the base, use the change of base formula with base 10 or base e. So let's look at the log base 6 of 23. Okay, first let's look at it as, let's try to estimate it. Estimate between two consecutive integers. Oh, well, 6 to the first power is 6. 6 to the second power is 36. So it's between 1 and 2. Makes sense? Okay, so next. So that's our first guess, between 1 and 2. All right, now let's use the change of base formula. So the log base 6 of 23 is equivalent to the log base 10, and we'll use 10 first, or natural log of 23 divided by the log base 10 of 6. So let's look these up. And this is common logarithm, so we can just hit the log of 23 equals, and we'll do 1.3617. That should be enough. The log of 6 is equal to 0.7782. So let's do that division there. We get 1.3617 divided by 0.7782. And we get roughly 1.7498. Okay. Now let's convert it to natural log. So log base 6 of 23 equals the natural log of 23 over the natural log of 6. Let's see what we get here. Natural log of 23, 3.1355. Natural log of 6, 1.7918. Do the division. 3.1355 divided by 1.7918. And I get 1.7499. So pretty dang close. Now let's check it. Remember, if we had the equation log base 6 of 23 equals y, this is the same as saying 6 to the y power equals 23. And this is our y. So use your calculator. 6 to the 1.7498. And I get 6 to the 1.7498 is equal to 22.9937. Let's look at the other one, 1.7499. That's a little closer. I get 22.9978. So this method works out pretty close. The difference is most likely due to our estimations. So that pretty much finishes up section 4.4. That'll do it for this time. And I will see you next time.